Well, we're getting close to the end of confidence intervals. We're going to talk about some properties of confidence intervals. Here we go, properties of confidence intervals, three things. If you increase the confidence level, the interval gets wider. That kind of makes sense because if you're going on each side of the mean a certain distance and you want to be more sure to capture the true mean, you're going to need a wider interval because it reaches out further and catches more values. So it makes sense that way. It also makes sense because as you increase the confidence level, the z star, which controls the size of the interval, gets bigger. Number two says, as the sample size increases, the interval gets narrower. Well, as you increase the sample size, the sample mean is likely to be closer to the population mean, so you don't have to extend the distance away from the sample mean as far to capture the population mean with the same frequency. So you can get by with a smaller interval and still capture the population mean, say 95% of the time. On the other hand, in the formula, the sigma over n, the standard error of the mean, explains how wide the interval is in addition to the z star value. And as n increases, sigma over root n gets smaller, so the width gets smaller. Number three, a larger sigma produces a larger interval. Once again, the sigma over root n controls the size of the interval in addition to the critical value, z star. A larger sigma makes sigma over root n bigger if n's the same size. That makes the interval larger. And on the flip side of that, a larger sigma means the population is more variable, and a more variable population means that the sample mean is more variable. And so it's easier for the sample mean not to be close to the population mean. So to capture the population mean the same percentage of the time, you need a wider interval. We have some examples over here. It says, suppose n is 100. Which one has the highest confidence level? It says larger confidence, wider interval. So we're looking for the widest interval. The widest interval here is this one here. Has width 4. Here the width is 2. Take this minus that. Width is 2. Here the width is 4. Here the width is 1. So the widest one. If the confidence level is 95%, which had the largest n? Largest n is corresponding to the narrowest interval. Large n, small interval, smallest interval. This one here looks like it's the smallest, from 49 pi to 50.5, width 1. Yes. And if C was 95%, n was 100, so confidence level and the sample size are the same. And those intervals were computed from different populations. Which population had the largest sigma? We said larger sigma, larger intervals. So we want to find the widest one. Oh, this is definitely the widest one. It's like 32 wide. This is like 1 and less than 1 wide. So we got that. Almost done with confidence intervals, and can't wait for this to be done so I can move on to some new stuff. Got a little bit more to do, and then I'll load up all these intervals on the internet, and you'll be able to see these on YouTube. Here we go.